Hello, I'm Alisher, and let me present you Spin Consensus Protocol, where we are trying to advance the bleeding edge of how you can build proof-of-stake blockchain these days. There is a well-known chicken and egg problem when it comes to launching new proof-of-stake blockchain. You need high value at stake to achieve economic security, but at the same time, for achieving that, you already need to be secure. And the blockchain is as secure as much stake is at question, right? And a malicious actor may hurt the network up to the point where it can take the whole control over it, right? So yeah, these days you can borrow security from a well-established network such as Ethereum or Bitcoin, becoming its layer 2. But this way, you completely give up your chain sovereignty and frequently sacrifice its scalability, its throughput, because you need to satisfy layer 1 validation protocol. So the question is, how can you build secure and scalable high throughput and low latency blockchain without $1 billion at stake from the very beginning? And we think in Spin, we figured out how it can be done in some cases. But another well-known problem I should mention here is blockchain scalability trilemma. Because of course you can make trade-offs and make your blockchain scalable and secure without requiring the node to be able to run on everyone's computer under the desk, right? But then how fault tolerant is it? How permissionless and trustless the network if it is controlled by a small group of privileged members? Yeah, there is a reason why high at stake, nicely decentralized networks are usually slow, because of course it takes time to replicate the data on a number of, on thousands of computers across the globe. So in Spin, we offer a fully sovereign, let's call it fast chain, to keep maintaining and growing its economic security and validators network being as secure as its stake allows. But at the same time, an additional well-established anchor chain could verify the fast chain proofs and provide the second layer of finality for it. But indeed, this picture is a little obscure. What are those proofs and how we can keep up the slow-moving chain with fast chain validation? For that, we are introducing the bridging gadget, which is an intermediary acting as an adapter of the anchor chain protocol, just decoupling the proving and validation, so removing the scalability limit. And yeah, this second layer of finality could be unnecessary if you are making a small transaction, just buying a cup of coffee by tokens, but for improving the fast chain Byzantine fault tolerance and improving its security for governance transactions, it is crucial. And those transactions can wait for additional 10 or 20 seconds of the anchor chain block. All right, so how do we facilitate fast chain block production? Here, the hardest point is the constant re-election of the block producer, because it makes physically impossible to make block time smaller than the network delay if you produce every block on a new ledger. So in Spin, we take the unlimited set of stakers, reduce it to a limited set of validators, and those events happen rarely. But those validators, they produce a consecutive sequence of blocks during their tenure. Yeah, and it allows them to produce blocks with a smaller block time. For the fast chain finality, the best gadget we found is Grandpa. Here, validators verify each block sequentially, but they then finalize them all at once. And this is super useful for our anchoring, because it also provides us a way to prove finality of those blocks at once. And having one node producing blocks for a long period of time, of course, you need some fallback mechanism, and here all the other validators are in a queue to step in case of the primary leader failure, working as a secondary leader. And secondaries produce special kinds of blocks just to make sure that the new primary leader is elected. Those blocks don't contain any user-submitted transactions, so it is easy to merge with a canonical chain in case of failures, and we avoid events such as double spend. All right. Also, the fast chain may suffer from finality failure, and here we are fine while the bridging gadget provides fast chain finality proof to the anchor chain frequently enough. Otherwise, we go back to the secondary leader block production and recover through the anchor chain. In the worst case, allowing it to remove the faulty leader and remove faulty validators to then allow the honest party continue correct chain block production. Another problem could be censoring, because we again have one primary leader for a long period, and here Yellow message framework helps us because it allows the user to submit any kind of fast chain transaction to the anchor chain, and then the primary leader should make sure that it is settled to the fast chain and provide the finality proof. Otherwise, we are back to the recovery. All right, yeah, that's Spin protocol in its shortest form. I would like to thank the Summit team, T, for this event, QF Network, of course, for sponsoring this research. I currently lead a small but mighty team of Spin implementers in QF. Thanks to Thunderella consensus developers, Spin heavily relies on their ideas, and thanks to PartyTech, we are using their substrate framework for implementing Spin currently. Thank you all, of course, for listening.